76 years. That is how long we called it a planet. Generations of children memorized its name. Scientists built careers studying it. We named it, mapped it from a distance, and believed we understood it. Then, in a single vote, we erased it. In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet. The solar system shrank from 9 planets to 8, and Pluto, the small, frozen, irrelevant rock at the edge of everything, was forgotten. We were wrong about all of it. Not just about the classification, about everything. About what Pluto was, what it contained, what it was doing out there in the dark. When we finally sent a camera to look at it up close, 9.5 years into a journey across 3 billion miles of empty space, what we found didn't just surprise us. It rewrote the rules of what a world is allowed to be. This is the story of how we threw away a king, and what the king showed us when we finally came to look. Pluto was discovered on February 18, 1930, by a 24-year-old Kansas farm boy named Clyde Tombaugh. He was working at the Lowell Observatory in Arizona, manually comparing photographic plates of the night sky, searching for the hypothetical 9th planet that astronomers believed was pulling the orbits of Uranus and Neptune. He found a tiny moving dot in the constellation Gemini. A dot so faint and so distant that it had been photographed before without anyone noticing it. That dot was 3.67 billion miles away. For the next 75 years, that was essentially all we knew. A dot, a name, a position in the solar system. Pluto was too small and too far for our telescopes to resolve into anything more than a smudge of light. We estimated its size incorrectly. We guessed at its composition. We imagined it as a simple, cold, geologically dead rock, a fossil of the early solar system, unchanged for billions of years, waiting patiently at the edge of the dark. Every assumption was wrong. On January 19, 2006, the same year Pluto was stripped of its planetary status, NASA launched New Horizons, a spacecraft the size of a grand piano, carrying 7 scientific instruments and 30 grams of Clyde Tombaugh's ashes, traveling at 36,400 miles per hour toward a world no human machine had ever visited. The journey took 9.5 years. Think about that. The engineers who designed the instruments that would photograph Pluto spent a decade waiting to see if their work had survived the journey. The scientists who planned the flyby calculated the trajectory years in advance, knowing they would have only one chance, one brief pass at closest approach, to capture everything. There was no orbiting, no second flyby. New Horizons would arrive, sweep past at 31,000 miles per hour, collect everything it could in a matter of hours, and continue outward into the Kuiper Belt forever. If something went wrong, there was no fixing it. On July 14, 2015, at 4:49 a.m. Pacific Time, New Horizons swept past Pluto at a distance of 7,800 miles, the closest any human object had ever come to this world. And when the images began to arrive, slowly, painstakingly, at the speed of light across 3 billion miles of darkness, the scientists in the control room went quiet. If Pluto surprised you, subscribe and leave a like. We are only getting started. The first thing they saw was the heart. A pale, perfectly shaped heart spanning 620 miles across the equatorial region of Pluto's surface. About the size of Texas and Oklahoma combined, so prominent, so geometrically distinct against the reddish terrains surrounding it that the initial reaction from the public was delight. A cosmic valentine, a message of peace from the edge of the solar system. The scientists knew better. That heart is not a symbol. It is Sputnik Planitia, a colossal nitrogen glacier sitting inside what appears to be an ancient impact basin roughly 1,000 kilometers wide. The glacier is not dead, not frozen solid. Beneath the surface of the nitrogen ice, Pluto's core still generates a tiny amount of heat from radioactive decay. That heat causes the frozen nitrogen to slowly convect, churning in massive cells, rising to the surface, cooling, sinking back down, endlessly circling. The entire glacier is in slow, constant, silent motion, and it erases everything it touches. Any asteroid or meteorite that strikes Sputnik Planitia is slowly consumed. The impact crater forms, then begins to sink as the nitrogen ice flows around it, dragging the debris downward and outward until nothing remains. The surface of this glacier is among the youngest terrain in the entire solar system. Geologically fresh, constantly renewing itself, pristine and white and hungry. At its edges, where the nitrogen glacier meets the surrounding landscape, mountains rise. Not mountains of rock. On Pluto, rock is irrelevant. The surface temperature drops to minus 380 degrees Fahrenheit. Cold enough that ordinary water ice becomes as hard and as rigid as granite. The mountains surrounding Sputnik Planitia are made entirely of water ice. Peaks jutting 11,000 feet above the surface. And because water ice is slightly less dense than the nitrogen glacier surrounding it, these mountains do not stay affixed to the ground. They calve away from the landscape and float. Massive water icebergs, some the size of hills, drifting slowly across the nitrogen sea on timescales of millions of years. A frozen ocean with floating mountains. On a world we call dead, there is something darker still. The weight of Sputnik Planitia, 620 miles of dense nitrogen ice, should have destabilized Pluto's rotation millions of years ago. The mass imbalance was too great. Pluto should have rolled, reorienting itself until the glacier sat at the equator, redistributing the weight. Scientists call this true polar wander. The physics demanded it. But for Pluto to have rolled without tearing itself apart, something massive had to be acting as a counterweight deep underground. Something dense enough to anchor the planet against the gravitational pull of its own glacier. The only explanation that fits the data is a subsurface ocean, a global layer of liquid water, kept from freezing by pressure and by the faint remnant heat of a radioactive core sitting silently beneath miles of ice in the coldest, darkest reaches of the outer solar system. We do not know if it is still liquid. Today, the evidence is indirect, inferred from the physics of how Pluto moves rather than from any direct measurement. But the models are consistent. The math works. And if Pluto has a liquid water ocean beneath its surface, here, 3.67 billion miles from the sun, in a place we called barren and dead, and not even worthy of the word planet, then the universe is telling us something important. Liquid water is not special. It is not rare. It is not a gift reserved for warm, sunlit worlds close to their stars. It hides in the dark. It hides in the cold. It hides beneath the surfaces of worlds we have dismissed and forgotten and stripped of their names.
Wherever there is liquid water, the question follows.
Could something be living in it? We do not know. We may never know. No second mission to Pluto has been approved. New Horizons is gone, pushing further into the Kuiper Belt, its cameras turned away forever. Tell me in the comments, does it change how you think about life in the universe, knowing that even Pluto might be hiding an ocean? I'll read everyone. As New Horizons sped away from Pluto in the hours after the flyby, it turned its camera back one last time. It captured an image of Pluto eclipsing the distant sun. And in that backlit image, something appeared that no one had predicted with confidence. A halo of blue, a thin, delicate atmosphere, glowing blue around the silhouette of a world we had called airless and simple. Pluto has an atmosphere of odd nitrogen and methane and carbon monoxide, thin, yes, and complex in ways we are still working to understand. That blue glow is sunlight scattering through haze particles in the upper atmosphere. The same physics that makes Earth's sky blue, happening here in the dark 3 billion miles away. We threw away a world with a blue sky. Pluto doesn't need our classification. It doesn't need our validation or our definitions or our votes. It has a glacier that consumes everything it touches. It has mountains of ice that float. It has red snow. Organic compounds called tholins raining slowly from the sky and staining the landscape the color of rust. It has a moon, Karen, so massive relative to Pluto that the two worlds orbit a point in empty space between them, locked face to face for eternity. And it may have an ocean hidden beneath all of it, cold and dark and patient, waiting for a question we are not yet ready to ask. The solar system has 8 official planets, but the edge of the dark is full of kings. Keep looking up.